Hello everyone, I am Shweta SV, Assistant Professor in the Department of ISC, SDMIT. The greedy knapsack is one of the algorithmic techniques for solving the problems which are optimal. Getting the optimal solution for a problem under the constraints matters much where it is subjected to the lot of constraints. The knapsack and the greedy knapsack is one such problem under this particular technique where there will be a knapsack, which means a bag of the certain capacity, and there will be certain items. Each item is specified with the particular weight and a particular profit to be gained from the selection of that item. The constraint in this particular problem is such that the selection of the items given in the number and the weight from those particular selected items should be less than or equal to the capacity of the bag, as well as the profit whatever we have gained from the selected item should be maximum as much as possible. This is called the knapsack problem. The greedy knapsack here compares with the formation of an objective function which aims at the maximization of the profit gained by the selection of the item subjected to the constraint where the summation of the weight of the selected items should be less than or equal to the total capacity of the bag. Let us consider one sample problem on this greedy knapsack where N stands for the number of items provided to you for the selection, whereas it is taken as 3. Then the capacity of the bag is mentioned as 20 kgs and weight and the profit of the each item in the problem is as follows. The item 1 weighs 18 kgs and gives 25 rupees of profit. The item 2 weighs 15 kgs and gives 24 rupees of profit. The item 3 weighs 10 kgs and gives 15 rupees of profit. The approaches to get the optimal solution for the problem is in these three following methods by a maximum value, minimum weight, and profit by weight ratios. Coming to the maximum value is the method where the greedy approach concentrates on selecting an item which is going to give you the highest profit. Whereas the minimum weight approach is such that the greedy method is concentrated on selection of the items which are having the least weight such that we can accommodate more number of items into the bag as well as we can get the maximum profit by that selection also. The third approach, profit by weight ratio, aims at selecting that particular item which gives an highest profit for a particular amount of weight to the bag. So this profit by weight ratio is an improved version compared to the maximum and the minimum weight. Let us apply these approaches on the problem what we have seen earlier, and according to that, by the maximum value approach, the items selected into the bag are the first item, because the first item is going to yield you 25 rupees of profit and that is selected. The item 1 weighs 18 kgs, so the remaining capacity of the bag is 2 kgs. Hence, those 2 kgs now is selected from the item 2 because it is the next highest profit in the given series. And hence, 2 by 15 of the second item is selected into profit 24 is multiplied, and we are going to get collectively 28.2 rupees of profit by the maximum value approach. Similarly, by the minimum weight approach, the items selected are the third item because the third item is having the least weight 10 kgs. And coming to this one, in the bag, out of 20, 10 kgs are over. Then the remaining capacity of the bag is 20 minus 10 is another 10 kgs. So the next least item according to the weight is item 2, which weighs 15 kgs. So 2/3 of the 15 kgs is 10 kgs. Hence 2/3 of the second item is taken. Hence the total profit obtained is 2/3 into 24 plus 15 from the item 3, which is collectively 31 rupees. A total profit of 31 rupees is gained from the minimum weight approach. By the profit by weight ratios, if you follow this method, the prerequisites are you have to compute the profit by weight ratio of the each and every item with the item weight and its respective profit. Once you calculated the profit by weight ratio of all the three items, arrange the profit by weight ratios in the decreasing order. Then we will do with the selection of the item which is having the highest profit by weight ratios. For the given three items, if we go through the calculation of the profit by weight ratios, the first item is having the 25 rupees profit and 18 kgs, which gives 1.3. The second item is having the 24 rupees of profit and weight 15 kgs, which gives 1.6. The third item is going to give the 15 rupees profit and 10 kgs, and it gives 1.5. On sorting in the decreasing order, on doing the selection, we get the selection of items like second item in the whole, and that is 1/2 part of the third item, and taking the collective profit of the 31.5. We can see the illustration of this particular problem like this solution. On arranging the profit by weight ratios in the decreasing order, you can see that one item 2, 1.6, item 3, 1.5, item 1, that is 1.3. So obviously, as item 2 is having the highest profit by weight ratios, take the item 2 into the bag, where the bag is filled with the capacity of the, that is 15 kgs. So remaining capacity will be 5 kgs. And the profit you are gaining by the selection of the second item is 24. So the profit you are going to gain is 24 rupees. Then the remaining capacity of the bag is 5, and according to the order, item 3 is having the next highest profit by weight ratios. So as our entire item is not going to fit into the bag, we are going to take the 5 kgs out of the 10 kgs, so which is 1/2 into 10. So the profit you are gaining is 1/2 into 15 rupees. So 24 rupees plus 1/2 into 15, which is going to give a collective profit of the 31.5 rupees. And the remaining capacity of the bag on selection of the item 3 into the bag is 5 minus 5 is 0. The bag capacity is fulfilled completely, and we have maximized the profit to its greater extent compared to this minimum value, maximum weight, and this profit by weight ratio. 31 profit by weight ratio is going to give you the highest profit of the 31.5. Hence, the fractional knapsack, the greedy knapsack solution is obtained for the given problem. Thank you.